In 12.3, we will learn about the measures of dispersion. Let's take a look at this graph. It says the shape of the distribution and variability or dispersion of the data. So we have one graph that is low and wide. That's considered a wide dispersion, meaning the data set is spread out further apart. Now, the one that's called a close dispersion is just basically the data set. All the numbers are really close in proximity. All right, notice both of them have the same center. They just have a different variation or a dispersion. So we think about dispersion as the measure of variability or the spread of the data set. One of the ways we can measure dispersion is by the range. The range is found by taking the highest data value minus the lowest data value. So let's take a look at this example. We have the age-oldest U.S. presidents listed, and we're going to take the highest age, which is 69, and we're going to subtract the lowest age, which is 64. That gives us a range of 5. So the range is 5 years, which is just another way to measure the dispersion. The problem with using the range is you have more than 2 values listed, and the range is only calculated using 2 values from your data set. So this can actually give you a false pretense of what a variability would be, such as maybe it is more variable than we think because we actually have more ages to look at. For this problem, it states for us to find the range for the group of data items. Once again, the range is the highest value minus the lowest value. So let's go ahead and say range is equal to, and our highest value is 25, minus the smallest or lowest value, which is 21. So our range is going to be 4. Another way to measure dispersion is by finding the standard deviation of a data set. Now, the nice thing about standard deviation is that it does depend on all the data items given. So you're going to use every value that you have collected, whereas the range only used 2 values, the highest value and the smallest value. To get started on finding the standard deviation, the first thing you'll need to do is find your mean. And the symbol that we're going to use for mean is called X bar. And remember, the mean is found by adding all your data values together divided by the number of data values that we have. So X bar is the mean or the average. For standard deviation, we're going to use a different symbology. And it is S sub X. And I'm using that because it matches your Casio 115 calculator. S sub X means the standard deviation. All right, the standard deviation helps us to identify how far away a data item is from the mean of our set. Find the deviations from the mean for the 5 data items. So again, here are those 5 data items. In order to do that, we need to find the mean. The mean is X bar right here, summation of all these numbers divided by 5. 5 is the number of values we have, and we're coming up with a mean of 66. So that is your X bar, 66. And then it says to find the deviation from the mean for each of the data values. So if you'll look at this table, on the left-hand side, we have our X values, our data item, which are the ages. And then to the right side here on the right column, we have 69 minus 66 is 3. And then they're taking each data value and subtracting the mean from it. And we have 2, -1, -2, and -2. At this point, finding the deviation from the mean this way would actually present a meaningless result, because if we were to add these numbers all together, we would get 0. All right, so that wouldn't make sense. So there's a little bit more to finding the standard deviation than just this part of it, but this is the step towards finding it. Continuing with the previous problem, As I mentioned, when you add the deviations together, you will get 0. Now, we can't do anything with the value of 0, so it doesn't make any sense to have a 0 dispersion. So in this case, besides a deviation, what we should be doing is finding the standard deviation. The standard deviation has a little more to it on its formula, and we will see that here shortly. But what we will probably do in this case is refer you over to the calculator and teach you how to use it so that you will know how to trust the results that you're getting. So in this case, the standard deviation, you take each of the deviations and you would square them. And then we have to do a little bit of manipulating on the formula and also take a square root. So you can see it's going to be a little more complicated than just uh, looking at a formula and filling it in. We have to do a little bit more work. So this is how you calculate the standard deviation for a data set. Number 1 step, find the mean. Next, we're going to find the deviation of each of the data values from the mean. Then we're going to square those deviations, and then we take the sum of those squared deviations, and then we divide that by n minus 1, and we take the square root of all of that. And this will give you the standard deviation. As I said before, the formula is a little more in depth. We have to do a lot of steps in order to calculate the standard deviation. And for the purpose of this class, we're going to be using the Casio calculator. I will give you the steps on how to insert the data values so that you can find your mean, also how to insert your data items so that you can find your standard deviation. The goal on using the calculator is so that you can focus on the result and make a meaningful understanding of what that result represents. So this one is referring to the standard deviation of a sample. So they're using the lowercase s as the standard deviation of a sample. So remember at the beginning we talked about a population versus a sample. So this is the standard deviation for a sample, lowercase s. All right, so again, we're not going to go through each part of the formula. What we're planning on doing is to use our calculator. I'm just going to make a note on here so that when you see these notes, we're going to learn about the calculator. The next 2 slides continue to complete the original problem about the age of the oldest U.S. presidents. And you can see on this table here, it has the list of the ages, the deviations from the mean on the second column. The third column takes the deviations and it squares them. And then you take a sum of all of these. Again, we're not going to go through all of this, but again, what they're doing is fulfilling the information we need to satisfy the formula. Continuing with step 5, we had the result of step 4 is 22. We'll divide by n minus 1, and we get the result of 5.5. Step 6 now takes the square root of 5.5, which will give us the approximation of 2.35 or 2 3500ths. What this means is the standard deviation for the 5 oldest U.S. presidents is approximately 2 3500ths years. Remember, we're talking about the dispersion, how the data set varies away from the mean. So our next problem is saying computing the standard deviation given the sample A, and they give us some values here. So the first thing you do is go find the mean. We list our data values, add them together, divide by 7, and we get 20. Again, they're going through the formula so that they find the standard deviation. The result on here is coming out to be approximately 2 1600ths would be the standard deviation. And the mean again is 20. A group of data items and their mean are given. So we have 1, 2, 3, 4, 5. We have 6 different data values, and they gave us the mean to be 350. Find the deviation, part A, from the mean for each of the data values. Find the deviation from the mean. So what we need to do is we need to take this first value, 250, and I'm going to subtract the mean, and the result is going to give me a negative 100. Right, so I have a negative 100. I'm going to do the same thing for each value. 295 minus 350, negative 55. 345 minus 350 gives me a negative 5. 350 minus 350, 0. 370 minus 350, 490 minus 350. All right, so these are the deviations from the mean, not the standard deviation, just the deviation from the mean. Then it says part B, find the sum of the deviations in part A. So if we were to take all of these values and add them together, the sum of the deviations, I wonder what will happen. So again, I'm taking my results and I'm adding them together, and we are getting 0. Again, the 0 is going to be meaningless because we're not going to understand how to measure the distance or variability from the mean if there is no dispersion at all. And that could happen. But in this case, with the numbers we have, there's some dispersion going on. Compute the mean, range, and standard deviation for the data items in each of the 3 samples. So we have 3 samples, sample A, B, and C. And it says, then describe one way in which the samples are alike and in one way which they are different. So when we take sample A, what we will be doing is placing this data set into our calculator. And I'll just quickly talk the steps through and show you some images on the next few slides on how to enter them. So we're going to press on the Casio 115 ES calculator. You press mode, and then you choose 3. Next, you're going to press number 1, and the number 1 should have 1 var, VAR, next to it. Then you're going to enter your data item. So after you place in a value, press your equal sign. It'll drop down to the next slot for the next number. Go ahead and enter all of your values in there. And then after the last value, and you have entered that, you're going to press AC. AC is real important because it saves your data set. All right, so after what we did was now we created our calculator to save our data set. Next, we're going to go in and we're going to do Shift. This will default you to the home screen. Shift and number 1. Then you're going to press number 4. And then if you want the mean, you're going to press 2. All right, this is for X bar. If you want the standard deviation, you will choose 4. So it depends on what you're looking for, your mean or your standard deviation. All right, so after entering our sample A into our calculator, then we go ahead and find our mean. We're finding our mean to be 43. The range is 36. That is the highest value, 61 minus 25. And then the standard deviation for this first one is 12.96. It says round to 2 decimal places as needed. For sample B, again, we're coming out with the mean of 43. Range is 36. and the standard deviation is 15.20. And then once again, when you go back through to enter your third data set for sample C, you will get 43 for the mean, 36 for the range, largest number minus the smallest number, and then our standard deviation is 18. All right, and it says in which of the following ways are the samples alike? So you can see that it is the mean and the range that they are alike. So I'm going to choose this option. Remember, you want to pick the best answer. And then it says, in which of the following ways are the samples different? And that would be your standard deviation. All right. Now we'll take a look at these values on a number line. So hopefully it'll make a little better sense about when we talk about dispersion. Continuing with that last problem, what I did was I took a number line and I placed our data values in accordance with each of the samples. So sample A is the first line, sample B is the second, sample C is the third line. Now on the right hand side, I placed the standard deviation that we found for each of the samples. So notice that the first sample A was 12.96, and if you take a look at our data set, it is pretty spread out across the number line. All right, and then when you take a look at sample B in comparison, notice our standard deviation increases to 15.20. So if you look at our data values here, you can see that our data items are farther away from the mean. All right, then in sample C, we have 18 for our standard deviation. And if you take a look at that, our mean is the 43, the solid dot in the middle of the line, but all the other values are well on the very end at our number line at 25 and at 61. So there is a larger dispersion or increased variability away from the mean. So the next few slides are going to give you the display for the Casio 115 ES calculator. The first thing you will do is to enter your data set so you can find your mean and standard deviation is to press the mode button and then the number 3. And then you'll press the number 1, which will say 1 var next to it. And that is this one right here. Next, you'll enter your data. You put in your value, press your equal sign, put in your next value, press your equal sign, and go through until you have all of your data set listed under that X column. And then when you're done with the last one, after you have pressed equal, you will press the AC button. Again, this is really important. It will save your data. Now, once you have your data set saved into your calculator, the next thing you want to do is to press Shift and then the number 1. Press the Shift button and then number 1. Next, you're going to press 4. And again, that will have the VAR next to it, and that would be this one right here on the screen. Next, you'll press 2. If you're looking for the mean, that is your X bar. And you'll press 4 if you want to find your standard deviation otherwise. So it depends on which one you're looking for. After you press the number 2 for the mean, it will default to the home screen and you will see this X bar on the home screen. For it to calculate the mean, you press your equal sign and the value will show up. So this value here happens to be from a previous data set with the, I believe it was with the presidents, the oldest president. The next thing we can do is when we want to recalculate, we do once again, Shift 1, press 4, then we'll press 4 one more time for the standard deviation. Again, you press equal because once you press the last 4, it'll default you to the home screen with this SX value listed. Press equal to get the value to appear. And that is how you find your mean and your standard deviation using your calculator. For those of you that are using other calculators, may I suggest that you contact the manufacturer's website to see about the manual and some steps on how to find and insert your list for your data set, finding your mean and your standard deviation. For this Casio calculator, what you want to do when you're done working is to reset your calculator by pressing mode and then choosing the number 1. And again, this is to reset back to your original so you can calculate normal values. So this last screen is showing the 4 different graphics of various deviations, standard deviations. The first one has a standard deviation of 0. Now it is possible to have a standard deviation of 0 if all of your values happen to be the same value, the mean. All right, and this one here has approximately 8/10, standard deviation of 1, standard deviation of 3. So notice we're going from 0 to a higher standard deviation of 3. We're slowly increasing. Look at the graphs as we are increasing. As the standard deviation gets larger, you'll notice that the values start to disperse away from the mean. So the yellow bars are showing on the second graph that we are falling to the left, lower, and then above the mean. And here again, we're still to the left and to the right of the mean. The mean is the green bar, but notice that the yellow bars are taller now. So it means we have a higher frequency. More numbers are falling away from the mean. And then over here on the final one, we have a larger dispersion because we have more data values that are falling farther, much farther away from the mean. And this concludes your lecture for 12.3.